I have my position function, so my velocity is going to be the derivative of that. And that's going to be 3t squared by using the power rule minus 3 times 2 is 6t to the 2 minus 1, which is 1 power. So this is my first derivative. If I want to find the second derivative, this is equal to v of t, this is equal to a of t. I find the derivative of v of t, which is 6t minus 6. So find the times at which the velocity vanishes. I want to say v of t equals 0. That equals 3t squared minus 6t. I have to factor that, which is 3t times t minus 2. And so I have two things multiplied together that equals 0. That happens at t equals 0. That's for the first one. And t equals 2. That's for the second one. Evaluate the acceleration at each of the times you found in the previous part in order to determine whether a relative maximum or a relative minimum occurs. So I have my second derivative, a of t equals 6t minus 6, and I want to use t equals 0. When t equals 0, a of 0 equals negative 6. And when t equals 2, I have a of 2, which equals 6 times 2, which is 12 minus 6, which is positive 6. We know that at t equals 0, we have a relative what?
When t equals 0, we have a relative maximum.
Exactly. And at t equals 2, we have a relative
Minimum.
Now we're going to do integration. These are our integration rules. The first thing we do is, again, we can use this rule. The constant times the function is, I can take out the constant. So that means the first thing I want to do is this. And then I want to find the integral of x to the n is the same thing as t to the third, right? A variable to a constant. That equals 8. That's from my front. And this is t to the 3 plus 1. Notice it's plus instead of minus. So that would be 4 divided by n plus 1, which is 4. We always put on this plus c, but we don't really need to put the plus c in whenever we have bounds. And let's just put the plus c in so I can show you why that's true. Okay, I'll put it in. So, and I want to evaluate that between 0 and 2. First thing I do is I plug in the top number, which is 2. And actually, the first thing I do is I'm going to simplify that to a 2. Okay, so now I have 2 times 2 to the 4th power plus c, right?
Right.
And then I subtract from that, I plug in the bottom number. So I plug in the bottom number and I have 2 times 0 to the 4th power plus c. And 2 to the 4th power is 16 times 2 is 32 plus c minus obviously 0 and then minus c. So notice the c's are always going to cancel, which is why when you have these bounds, like the 0 to 2, you don't need the C. But if you don't have bounds, you do need the C. Now we have a product of two functions here, don't we? But I don't see a product rule here, do you?
No.
That's because there isn't a product rule. I just multiplied that x times everything. This becomes 10x minus 3x to the third dx. And now I don't have to worry about a product. I integrate. So I have 10 times x to the n plus 1. N is 1. 1 plus 1 is 2 divided by 2 minus 3 x to the fourth divided by 4. And I need to evaluate that between 1 and 2. And I don't need the c. As you can see, we've already taken care of that. This becomes 5. I have 5x squared minus 3/4 x to the fourth between 1 and 2. And now we're going to plug in our numbers. We have 5 times 2 squared 4ths times 2 to the 4th power, which is 16. You don't really need those parentheses, but you do need the second set because I'm going to subtract off when I plug in 1. So that's 5 times 1 squared, so it's 5, minus 3/4 times 1 to the 4th, which is 3/4. So this becomes 20 minus, this cancels with this and makes it 4. So I have 20 minus 12 minus, and I'll put these all into the same, I'll put 5 into fourths. So I have 20 fourths minus 3/4 is 17/4, right? And I get 8 minus 17/4. 8 is 32/4. 32 minus 17 is 15, I believe. 15/4. I believe that is right. I would just leave it as 15/4. I have sine of pi t. And if the derivative of the sine is the cosine, then the integral of the cosine is the sine. Or you can look here. The integral of the sine is going to be the negative cosine because the derivative of the cosine is the negative sine. So we are going to get negative cosine of pi t over pi. And I'm going to evaluate that between 0 and 1. And I'm going to actually factor out that 1 over pi. And then I have the cosine of pi times 1, which is pi. Then it would be minus cosine of 0, which equals minus 1 over pi times cosine of pi is
-1.
perfect. -1 minus cosine of 0.
1.
Perfect. This becomes -1 over pi times -2, or 2 over pi. And that should be the answer. Again, I want to integrate this. I have a formula for that. I say that's e to the minus 2x divided by minus 2. And I evaluate it between 0 and 3. This equals minus 1/2 times e to the minus 2x, evaluated between 0 and 3. So now I have minus 1/2 times, and then I plug in the 3, I get e to the minus 6. And then minus, I plug in 0, which gives me e to the 0. Everything to the 0 is 1. There's my answer. And that's it. There's nothing more to do. But first, I don't have a square root in my formulas, so I have to change this to t to the 1/2 power. And then I integrate. So it becomes t to the 1/2 plus 1, which is 3/2, divided by 3/2, evaluated between 1 and 2. Keep, change, flip, however you want to talk about it. This is the same as 2t to the 3/2 divided by 3 between 1 and 2. We have 2/3 times t to the 3/2. T, first we plug in 2, and then we subtract and we plug in 1. This equals 2/3. I have 2 times the square root of 2, and then obviously minus 1, because 1 to any power is 1. And, I can simplify it. So let's see, we can get, actually, that's as good. I think that's perfect, just the way it is. I don't want to do anything to it.